Hello, everyone. We got a great audience today and a great presenter, and we're going to go ahead and get started. Welcome to This is CDR. Happy New Year to everyone. This is CDR is an online event series presented by OpenAir to explore the range of carbon removal solutions currently being researched, developed, and deployed, and to contextualize them for policy proposals that OpenAir is seeking to advance really at every level of government here in the United States, as well as in national and subnational jurisdictions globally. My name is Toby Bryce. I work on policy advocacy and market development with OpenAir, and I'm based in Brooklyn, New York. If you've not done so, please go ahead and introduce yourself in the chat and let us know where you're zooming in from. Just some quick background on OpenAir. We're an all-volunteer network dedicated to the advancement of carbon removal solutions that are essential to solving the climate crisis. We're a global community. We work on what we call missions, which are really open source projects, really global at this stage, all across the world in the areas of research and development, messaging and communications about carbon removal, policy advocacy, and then some activist market development, trying to get CDR up and running and out in the world. Tons of projects up on our website. Our co-founder, Chris Neidl, is running the chat, and he'll put some links in the chat to orient you. There's a form you can fill out to sign up and get on our Discord, and we'd love to have you be a part of what we're doing. We always start the program with a little bit of a quick background on carbon removal. This definition here is from the CDR primer, which is a fantastic resource. And again, I think Chris will put that link in the chat. It's also essentially the same definition that the IPCC uses. Carbon removal is a purposeful human activity to remove CO2 from the atmosphere and to durably store it in geological, terrestrial, or ocean reservoirs or in long-lived products. Two really important things to call out when we talk about carbon removal. Number one, it's really important to disambiguate carbon removal from carbon capture, quote unquote. Carbon capture typically refers to capturing CO2 from an emission source, whether it's a natural gas power plant or a cement plant. That may or may not be a good climate solution based on the specific socioeconomic, techno-economic, environmental, and other considerations relevant to the specific project. But one thing it's clearly definitely not is carbon removal, which again is removing CO2 from the atmosphere and then putting it away for a long time. In storage. Number two, when we talk about carbon removal, it's critical to call out that carbon removal is in no way, shape, or form any sort of substitute for reducing emissions. We need to reduce our greenhouse gas emissions and decarbonize our global economy as quickly and as completely as possible, full stop. Nothing should really distract us from that. That said, there's clear scientific consensus expressed most recently expressed most prominently in the IPCC AR6 Working Group 3 report that gigaton scale carbon removal is going to be required by mid-century if we want to have any chance of limiting warming to 1.5 or even 2 degrees Celsius. Gigaton is 1 billion tons. It's a tremendous volume. We're currently at thousands, tens of thousands of tons of long duration carbon removal. So we really it's really important that we get working on carbon removal now. There are 3 fronts we need to be working on. We need to be reducing our emissions. We're going to have to adapt to an already changing climate, and we're going to have to remove CO2 from the atmosphere. Going to go ahead and pass it over to my colleague, Megha Raghavan, and she's going to talk a little bit about today's run of show, and then she's going to introduce our speaker, our presenter. Megha.
Hey, everyone. I'm Megha. I'm an OpenAir member based in London, and I also work on policy advocacy as well. So as usual, we'll start with a short presentation, followed by a few prepared questions, and then we'll do moderated audience Q&A. So please type any questions you have into the Q&A box in Zoom. It's separate from the chat box, so make sure you find the right one to help us organize it a bit better. And the event is being recorded, so we'll send the video link out to everyone who registered, and we'll also post it to OpenAir's website and YouTube channel. This week, we're very pleased to welcome Carbo co-founder and CEO Henrietta Moon, who will present the company's plan to scale biochar production via its patented Carbolysis process that converts residual biomass into biochar and heat. Henrietta has wide management experience, having founded an education startup and launched and scaled several high-profile global initiatives in technology. She was the youngest person in Finland to be a board member in a publicly traded company, and she is recognized as a World Economic Forum global shaper and a member of the Stanford-StartX founder community. So Henrietta, whenever you're ready, over to you.
Hi, everybody. So lovely to be here. I see a lot of exciting people joining. I can't keep on seeing everybody where you're joining from, but super, super lovely. And thank you for for joining in this Zoom age. It's great to be here today. I'm going to open my presentation shortly, and I'll run through about 20 minutes of presenting carboculture and what we're doing, what we're up to, and then I'd love us to have a really good conversation afterwards. Perhaps there are some questions that you can start thinking of and so forth, but I know that there's some biochar people here. I know that there are other carbon removal people here, so super, super exciting to kind of share knowledge and have a good chat afterwards. Great. Without further ado, I'll jump in. Maybe I will move this bar to be a little bit more invisible. All right, let me know if there's any problems in how you're viewing the slides. Great. I want to talk about amplifying natural carbon cycles into permanently removed carbon dioxide. Obviously, for the biochar people here, you're very clued in, but carboculture exists like not just for our mission, but from the belief that actually nature is already drawing down billions of tons of carbon dioxide annually, and now we just need to turn it into a permanently stored version of that. And of course, as many would agree, photosynthesis is one of the largest shapers of our planet, and so we should tap into this wonderful resource that we have at hand when we are thinking of how do we fix the climate crisis. As was mentioned just now, the IPCC has outlined that we really need to get carbon removal up and running, and the market is humongous, and carboculture doesn't believe that it's a winner takes it all market. There's going to be many solutions catering to this huge need that we have. And as we just heard, the capacity today is so low, it's sub 100, definitely sub hundreds of thousands of tons, or sub million tons for sure in the removal space, and we need to get that to the billion ton area. So I think what was the last numbers from the EU? I think we're under 100 million tons globally, including forestry projects. So there's a lot of work to do, and biochar's potential has been estimated between 0.5 gigaton and 2.5 gigatons, so somewhere there. And even with a stab of that would be a huge market to cater to. And of course, then there's all the other forms of carbon removal as well to service that market. And this, of course, is if we actually manage to reduce our emissions. So lots and lots of implementation and infrastructure and financing and all sorts of work that has to go into this if we are to meet these targets. Like was mentioned, what is carbon removal? It's many things, and why biochar is such a neat way to do carbon removal is really that plants draw down the carbon into biophotosynthesis, and then we convert that carbon from the plant matter into a stable form, which is then stored in a biochar format very safely for hundreds of years, if not millions of years. And this all leads to carbon removal then. And now how carboculture does it is that we take biomass waste, such as forestry waste or food processing waste, residues such as nut shells or peach pits or sawdust waste. We put it into our patented reactor, and we take it, it's a batch process where we take it to an ultra high temperature for a split second. And we do that by actually using air pressure in the system. So actually we combust through the material ultra rapidly. And this leads to an exothermic reaction. So actually, if in a way you're thinking about the reactor like this, we actually go through the material in a way that we combust through it. And this way we get to high temperatures, which lead to high permanence, high purity, and so forth. And instead of making bio oils and biochar, we actually only generate the solid material, which is the biochar, the biocarbon, very clean. So, 80–90% fixed carbon. And then we generate a huge amount of excess heat in the form of syngas. So really looking at a lot of megawatt hours there that can be utilized. And then, of course, there are the carbon removal credits that are counted from the physical biochar with laboratory tests, a full life cycle assessment of all of the transport and the energy use for the system, and of course where the biochar is being used and so forth. So all of that leads into the calculation for how many carbon removal credits you actually can generate with your system if you go the accredited way, which we have with Puro.earth currently. And so this is really exciting when we're thinking about the current energy crisis in Europe, for example. Heat is really, really needed. And so if we can help the grid go greener by generating huge amounts of heat, that's really, really, really good. And somebody asked, I know earlier, like, what is the rough mass energy balance? So if we take 4 tons of 3 to 4 tons of biomass, we generate 1 ton of biochar, generate about 10 megawatts of heat, and then about 3 tons of CO2 removed. So it's a very good conversion rate, and all of these 3 products are, of course, commercializable and various revenue streams for us. The renewable heat market is obviously very well established in Europe and so forth, and a lot of industrials need heat. The biochar market is newer, and then the carbon removal credits are becoming quite a established market with better offtake contracts, longer term and more sturdy counterparties and so forth. And I'd love to talk about that maybe in a bit. So I think when we look at all of the carbon removal solutions, like, it's clear that there's going to be a bunch of solutions catering to this market. But what we need today is solutions that are not going to burden the grid more by demanding huge amounts of energy right now. So I think that there are solutions that are really scalable. For example, all the forestries of the world that should be going on and so forth, they're perhaps less permanent. But then in our space, biochar is a nice melange of that permanence and the low energy requirements, and of course the easy packaging from nature in terms of the carbon being in the biomass, and then later on in the biochar, which is safe to handle and so forth and so on. So really the storage is solved for. The energy required is really negative, so we can actually generate energy and help with the green transition instead of putting more needs on it and so forth. But I do believe that there are many solutions that can work even with high energy needs once we solve baseload power. So perhaps I would look at this as a little bit of an old chart, but maybe we should start thinking about CDR solutions that are, for example, deployable today, deployable in 3 years, deployable in 5 years, and so on and so forth, because we will have lots of solutions coming online before 2050, which will have different kind of attributes to them. So our kind of 18-month roadmap, or where we are, so we've done our pilot systems, which were based on university research, which was academic research for over a decade. From there, we scaled up the technology, flew past in development, and managed to last year actually get our commercial scale reactor to work, which is very exciting. Now, next week, we're moving into our reactor 3. On Monday, we're breaking ground in Finland, which is very exciting for our last test system. So it's going to be an automation rig. So basically taking what we have in technology and taking it into a 24/7 operating system. And then our first commercial facility will be online, in the end of next year. And that's a huge lift from the whole team. It's a proper infrastructure project with detail engineering and EPCM and so forth. And we're looking to build it to project finance principles, which I think we should discuss later after I've run through some of these slides. And I know there might be questions on this as well. So again, like, why are we building our first commercial facility, or obviously on the way to scaling out, there are all sorts of solutions. But the reason for us to build a first commercial facility, really something that can operate with commercial partners for a long term, built to industry standards and safety and all of that stuff, is really to demonstrate that, hey, our team knows how to do this, and now we can go and fund a bunch more of these. So if we learn from, for example, the clean tech successes of the past, the wind and the solar and all of these industries that were financed with project finance, we know that there's a certain set of rules that the industry works with, which need to be, for example, operating at standard processes and principles, of course, but also having a stability in the running hours that needs to be proven. You need to have contracts that are actually bankable, which means that when a bank looks at it, they will lend you money against it. So it needs to be a bankable counterparty. It needs to be, good terms, of course. You need to be able to fulfill that contract, and there need to be, minimized risk in those contracts. And so that's why, for example, an offtake contract of heat is very attractive to them, because it's super boring. And so really long-term known contracts are great. And here I think the carbon removal market and the purchasers are also starting to understand that companies will need these kinds of multi-year offtake agreements, because that's what you can go and finance a facility off of. So this is really key is to have some sort of a structure where you can source long-term partners, not just, of course, customers, but also the other people who are going to be involved in making the company a success. Then obvious thing is your team needs to be able to bring this thing to life. So you need to show that your team is capable of taking a project from start to finish, delivering a ready project, if possible at budget and at deadline and so forth. And you need to show that you have those capabilities either in-house or how you do that with your partners going forward. And this is, of course, for any company that's looking at real steel and so forth. These are things that we need to start thinking of. And really, this is all to demonstrate that this whole thinking is around project finance principles. And now this is a very long sentence. Maybe I'll take a sip of tea while you read it. Now, I don't believe that the climate crisis or carbon dioxide removal or anything like that will be funded by venture capitalists. To an extent, they will help companies get there, and of course supercharge the companies that get capital from VCs and such with their knowledge about how to build companies. But really the big lift on projects and infrastructure and the heavy machinery and capex and really long-term stuff like 15 to 20 years out, that has to come from project financing and really the banks and the lenders and the infrastructure investors out there. And so we need to learn as an industry. We don't have the luxury of 20 years of time that solar or wind had when everybody got comfortable with how those projects are run and what the risk profile is and so forth. So now we need to fit into that kind of a project category. And of course, great if the financiers can meet the projects a little bit earlier than they're used to, because this is a new industry and we don't have time to get everybody comfortable with some sort of whole new factor of risks and ways of doing things. So that's why there's a lot of learnings that we can have from wind and solar and so forth. And basically this bankability and bringing the CO2 price to market, so really where the customers want it to be seen, so that you can do those long-term offtake contracts, so that you can access that financing, so that before you even go and build the facility, you have the facility already contracted. So I think that that's where the vast amount of financing for the transition and for our type of solutions will emerge from. I'm curious, of course, to hear where people's experiences have been with this, but this is definitely something that we're hearing from the market. What kind of plant matters do we turn into CO2 removal? Well, like, many of the biochar systems, there's a lot of different kinds of biomasses that you can use. And again, we just believe that photosynthesis is the fastest way to do this. And currently we're using waste materials. So food industry waste that accumulates in one site, industrial waste, again, that's sawdust from sawmills or some other byproducts from the wood industry or lumber industry or something like this. We don't use, for example, virgin wood at all. Or industrial waste from other types of solutions, but again, just clean waste. So our solution is not for burning plastics or anything else like that. And here, we're not really affected by impurities. So if you think of a ethanol process or something like that, if you drop a glove in there, it might, not work for a day or something like that. But we're operating at such a high temperature. And by the way, don't quote me on that. I don't know anything about ethanol production, but in any case, many people have asked us about the stability of the process and so forth. But we're not affected by impurities because we're operating at such a high temperature. So any of that stuff will just be burned off. And then again, it's a fairly straightforward process. We don't use any chemicals or anything like that. So really neat and clean. We have a nice team forming with really, really good people. Our new VP of engineering just started. We got a headhunter a couple of weeks ago and so forth and so on. So really shaping out the team nicely and yeah, couldn't be more happy with the people that we have on board right now. It's a privilege to be working with them, and yeah, so happy that they have trusted us to join our journey and so forth. And of course, we are looking for more people. So a little plug here before we go into Q&A, but we have all sorts of roles opening up this year as well, from environmental analysts or legal counsels to the more business side of things in biochar sales and then of course to engineering. So any kind of industrial engineering processes that you can imagine, process engineers and safety and so forth and so on. So lots of good stuff there. And yeah, happy to start taking in the questions. Thank you very much.
Thank you, Henrietta. That was great. We are going to be doing audience questions in just a few minutes, and please put those in the Zoom Q&A box because it's basically impossible to manage them if they're in two places. So please, if you have questions, put them in the Q&A box. And Henrietta, that was fantastic. Thank you. We always like to start just by hearing a little bit about the presenter's sort of personal journey to where you are now to carbon removal. Can you tell us about how you learned about carbon removal, when you started thinking about it, and maybe just a quick origin story about carboculture?
Yeah, I'm Finnish originally from Helsinki, and I met my co-founder Chris Carstens, who's Californian, at a program called Singularity University almost a decade ago. It was a nerd camp or a space camp, we called it, which was a 10-week program at the base and in Moffett Field, and we were tasked to think about stuff that impacts the world in a positive way. So there, some of the other stuff that came out were, for example, cancer treatment, or women's rights, or some other types of solutions, and the more technical ones, of course. But in any case, we were one of those teams, and Chris, my co-founder, he really had been thinking about all forms of carbon, from fuels to the actual drawdown of carbon for decades before I met him. But in any case, in 2013, there was no market for carbon removal, obviously. And so I was running my previous company, which was an educational technology company. So a lot of kind of like media lab type personalities, and in a very different space. But I had been active in the startup space in Finland and Europe for, a decade or so. At that point, or maybe not that long, a half a decade maybe. But in any case, fast forward a few years from there, I just couldn't stop thinking about how climate is going to become such a nightmare, and nothing else really seemed like it was worth doing, to be honest. And so we at the end of 2016, we applied for a challenge with Chris using this idea of really making biochar in this way. And we didn't get into that challenge, but in any case, we formed a team and started a company and so forth. And then in January 2018, we closed our pre-seed round, and that's when we purchased hardware and started really getting going. So I'd say we've been getting going from there. And our first system was in California. That's where I was living as well. So we're like a Nordic Californian mix. And I think that speaks a lot to our values as well. And of course, the environmental values are very strong in both of those areas. So it's no wonder that we focused on this. But carbon removal really kind of like, it's been verbalized as that only for the past couple of years, because when we got started, we were a soil amendment company. And of course, we knew that it's to take carbon dioxide out of the atmosphere, but the European trading system was trading at €5 a ton, where it's now at €100 a ton nearly. So things have changed, luckily, in the past couple of years, very much.
Yep, that's great. Thank you. I want to drill down a little bit into what you said about the carbolysis process, the thermal conversion process of the biomass feedstock into the stable biocarbon. And the reason that one of the questions sort of in I think the long duration carbon removal community about biochar, there are two, the durability, which we'll get to in a second, and then the carbon efficiency of the process. And you hear estimates as low as 20 or 30% of the carbon from the feedstock will ultimately end up in biochar, and the rest is emitted, basically. So the numbers you gave, 4 tons of feedstock leads to 1 ton of stable biocarbon, and then 10 megawatts of heat.
Yeah. So the way to think about it in terms of like absolute carbon is about 50% gets sequestered in the biochar itself, okay. And then 50% we convert into syngas. So in this case, it gets in our first facility, we're going to sell it to municipal district heating. So basically, for anybody who's outside of the Nordics, you heat up hot water and then you pipe it all around the city. And that's a very efficient way to heat any, not just, living buildings, but also industrial complexes and so forth. So it's a very, very Scandi thing.
Yeah, that's cool. And Boise, Idaho in the US has a district heating system.
Okay, excellent. So I heard of one in London under the underground somewhere in
it's
city.
Great.
And
it teams up very well with biochar. And the reason, and you said you don't produce any other byproducts because of the extreme height, 850 degrees centigrade heat. Is that correct? So it's literally just syngas and
yeah, basically the tars get turned into gases at that temperature, so we don't get those condensates or the sort of bio oil, if you want to call the toxic, or like the tars that come off of some of these processes.
And you capture the syngas, and then that gets transported to the heating company, or the?
Yeah, no, it's actually pretty straightforward. It's post-combusted, and then we use that heat to heat up hot water, and then there's a heat exchanger, and then we pipe hot water and we get cold water.
So the heating happens in situ at the plant.
Yeah.
Okay, got it. Very cool. And then the other question, you made in the company statements and on your website, you talk about 1,000-year plus durability. And again, like one of the questions in the community about biochar has been the durability. And can you talk about the specific scientific basis, like what kind of research you're pointing to sort of validate that statement?
Yeah, I mean, this is so interesting that it's a topic. So when we talk to people at for example, Cornell, they were like, you can't even get a PhD on this anymore because it's so done and dusted that biochar is permanent, and there's so much peer-reviewed literature on this. So the idea that it's somehow contested is really interesting. But in any case, I guess for any carbon dioxide removal permanence mechanism, and now forgive me, I'm not a scientist, but you look at data that you get from a laboratory or from the real world. And so for us, for carbon, I guess it's mostly laboratory results that have been looked at, but then of course there are real world examples of carbon in nature, such as the terra preta, or even if you look at coal, it's like 400 million years old. So how long has that been around, and how is that preserved so well? And you know, how long does carbon live? Well, my co-founder likes to say that if you ask a geologist or a soil scientist, they'll answer two different things because they think of things in different time spans. But really, I guess what we claim is leaning on the SPOCAS paper, so the oxygen to carbon ratio and so forth and so on. But in any case, we send our biochar to a laboratory, to Eurofins, and they give us a lab result of what exactly our carbon is made up of. And in addition to that, some of our carbon has been used in some durability studies as well. So yeah.
Okay, and the paper is at SPOCAS, SPOKAS.
Yeah, exactly. I can try to Google it and link it here, but it's and then of course, what is it? Where that CDR primer was from? Actually, I can't remember the website, but they have their own calculation as well for the permanence, and I think we're at 700 years according to their permanence calculation. So you know, but let's see who's around to verify that.
Exactly.
If it's 700 years or 1,000 years. But I think, you know, it's an interesting topic to think about. And now, like, I would beg the question, like, is it really important? Is it 5 years? 500 years or like 500,000 years? Like, is it really, really important for the climate crisis at hand? And like, I don't think it is. And I think what is important for the climate crisis at hand is how soon can we get to a gigaton, and with what solutions at hand, and how much pressure are those solutions gonna put on other stuff like energy or land use or something else. And biochar should and biochar is being asked the question, you know, often that where does the biomass come from, and what's the impact on land use and so forth. I think that's an excellent question, but whether like the sort of like permanence debate, whether it's 10,000 years or a millennia, like, I don't know. But yeah, we can, I'm sure there's new science coming out on that as well. So it will be interesting to see that. But we'll have to try to frame something like that on our website. Like, where does that actually come from, and how can we point to that? Because it seems that it's a lot of people ask that question. So clearly we haven't been able to communicate it.
It's definitely a question. I think maybe it's less of a question in the biochar community as it is external to the biochar community. But yeah, I do think that would be a good communications exercise. And there's also a tremendous amount of current writing and thought about the different valuation of different levels of durability, like, you know, 5, 20, 100, 1,000. I definitely agree with you, 10,000 versus millennium. That doesn't
exactly
matter,
but let's like keep in mind what's like really important is that like 2050 and 2100 is like when we're gonna overshoot the planetary warming targets, and that's when things start messing. Like, we're already seeing that the Arctic summer ice might not return. Like, things are going to happen in pretty near years.
Yep.
And we need to be able to bring solutions that actually can help us in this crisis, like today. And I fully applaud the scientific effort to figure out whether it's like 1,000 years or 10,000 years. That's great, but also like, let's just get stuff done as well.
Yep. Well said. On the project finance front, I've heard you talk about this quite a bit in other forums, but you know, it's a huge challenge for the sector at large to finance first of a kind installations, plants, facilities, projects. And I hadn't thought about this, but the fact that you can at least help your carboculture financing with offtake on the heat, how much of an advantage is that to you specifically? Do you sell the char, or is it purely the credits? And then, you know, like how is carboculture facing the challenge of like the first of a kind financing, and what are your thoughts on that?
Yeah, we need all three revenue streams for sure. So definitely need to commercialize all of those. The heat is helping a lot because it is such a stable thing. Basically, when your off-taker is a municipal district heating system, they're not going to go bankrupt. They're not going to disappear. They're going to be there for the next years, and that's something that's really great for financing, because they want to see something that's, steady and predictable. And so definitely helping us. But first of a kind is just so tough, right? It's going to be always, I mean, if somebody else has another way of doing it, very curious to hear, but it's always going to be a mix of, can you get grants? Can you get non-dilutive financing? Can you get a loan that's government backed? Can you get your shareholders to give loans and so forth? Because the first of a kind is something that project financiers won't touch. They will come in after the second plant if your first one gives the good data. If you have solid run hours and this and that, then of course you can access financing after that. But until that happens, it's fairly difficult. And so yeah.
Yep. Well, it's nice that you do have those other two revenue streams, which many carbon removal companies and methods do not have. We have 38 audience questions and counting. So I'm just going to ask one more question from OpenAir. And it's one we ask all our guests, but we'd love to hear you talk about how you and Carbo culture think about equity and environmental justice with respect to your deployment, your scaling. There are a couple of different dimensions for a company that uses biomass. You referred to, you're currently working with residual biomass, which obviates some of those questions. And then I guess the other thing is that, does your process have any negative externalities that you need to be thinking about for surrounding communities? Can you just talk a few minutes about that topic and just tell us?
Yeah, for sure. So like our first systems, well, excluding California where our test system is, but our first systems will be in Finland, and the environmental permitting is pretty stringent. So definitely we have to go through all of that and make sure that we're abiding by all of those laws and so forth. But that being said, when something's zoned as an industrial area, then it's totally fine for us to build there, because we're using clean fuels. So just as there is a biomass power plant, next to it, we would be using far less biomass in the process. So really, it's fairly straightforward for us. I think where we need to be careful is the biomass. So really making sure that we don't impact biodiversity or somehow have negative consequences down the line. And for us right now, it's fairly straightforward. It's definitely not our first problem, as in like there's millions of tons of waste biomass available from industrial processes, underutilized, resources that just aren't near a suitable use location or can't be used in biomass energy because of its content of some minerals and et cetera. So there are pockets that we can tap into, but let's say when we start scaling out properly, then we definitely need to have a better strategy in this and actually talk to also the leading scientists in the space, not just rely on our own knowledge in this space.
Got it. Excellent. Thank you. Megha, do you want to come on and start asking some audience questions?
Hey, yes, we have quite a few. So in advance, I'm sorry, I'm not going to get through all of them. But just wanted to start with one, which we got a few people asking about this. So just thinking about, I guess, the biochar you produce and the properties it has, whether based on, feedstocks or the process or anything else. Can you just talk a little bit about like the properties of your biochar, and then how do you kind of pull together, the feedstock, what the market is actually looking for, and biomass availability to make sort of the right combination of those three?
Yeah, I mean, right now, like I'm going to give a very simple answer because this is not something that we're anyhow excelling in, but basically, of course, what you put in affects what comes out, but your process does affect the typical quality of what it actually is. So for us, for example, it is a very high carbon content, very inert and stable carbon that comes out because of the process that we're running. But now we are targeting soil applications, mainly, a little bit of some other stuff on the side, but we're really targeting the soil market because I'm also so excited about the potential that biochar has to limit other greenhouse gases, et cetera, in that market. But in any case, there, I'd say that the variability is less strict as it would be for some material, properties and so forth. If you're doing something very niche like a material science application, then you obviously have to be able to replicate your biochar you know, for X thousands of tons, but for us, it's a little bit more relaxed. But that being said, how we do it right now is that any feedstock that we're intending to use, we actually have to run a pallet of tests through, and of course get the laboratory results, and then work with the customers to do some pre-testing before we can start selling it, unless the customers actually know what, you know, how to use it and so forth, and know how to mix it. Then it's a little bit more relaxed, and then we just make sure that we meet EBC requirements and get proper like third-party laboratory tests on it before we start selling anything.
Got it. Okay. And then just in terms of the actual siting of, you know, the plants, what kind of things do you have to think about? Is it mostly about where the raw materials are, the thermal off-takers, like what kind of considerations go into the decisions there?
Yeah, unfortunately, we have to think of a lot of things. So it would be so nice if everything was a silver bullet, but actually we do need to think about the location of the feedstock, obviously, where that's accumulating. Then the heat off-taker. A lot of these industrial processes will need heat, so they could be potential heat off-takers, but also there's municipal district heating networks that we can tap into. Some cities have larger ones than the other ones, so that's always a factor for us. Then, of course, the off-taker and their reliability standards. So when we're building a first one, surprise, we don't have reliability data for a commercial facility. So that needs to be taken into account, et cetera, et cetera. So there's quite a lot of things that need to be considered when planning a facility location. And of course, also that you're allowed to build there and it's a solid place, so you're not disturbing people, but yeah.
Yeah, totally makes sense. Okay, and then as you think about scaling that up, like, is that going to change the kinds of locations that you need to consider, or is it pretty much the same considerations that are going to carry through?
Yeah, I mean, I think like, as in with any infra project, it's just a pipeline of places that you're really looking at, and then you start figuring out which ones are the most suitable for you, which ones can you move with fastest, what are the areas where you can do, you know, some things faster, can you use the same partners for some sites and so forth. So I think really it's about like what fits your business needs and how can you accelerate that process in a way that, you know, you can start thinking about deployment in sort of sets of facilities instead of individual projects. But of course, that's like, it is like one step still for us to learn is really like, how do you do that then 10x what you're doing right now.
Okay, got it. Yeah. A couple of people kind of talked about the sort of modularity options or like the size of each location. So is there kind of like an optimum size of a facility that you have in mind? And then some people also did ask, like, do you see potential for people to kind of have their own backyard reactors and do it in a really distributed fashion? So what do you think is kind of the optimum on that scale?
Yeah, I mean, like, really, if we think about biochar, like, it's fantastic that it is such a grassroots, you know, movement and so forth. And definitely those backyard systems should continue to exist and you know, flourish. And there will be some systems that will be very different to ours that might be better suited for in situ, you know, conversion. Like, I don't know, New Delhi has horrible pollution from you know, burning the crops in the fields. Why don't we just turn that into char or something, like maybe in a more efficient way that's less polluting? So maybe there are some robots could do that for them, but then that's not the way to do it if you want to, you know, use the heat from the process and actually do it in a more industrial scale. So this is, you know, this is our approach, and we think that this is the way that we can get to scale. There should be a plethora of other approaches as well to thrive. And again, like, if we're looking at 1 billion tons of loose biomass in the world, it's going to come in many different shapes and forms and locations, and all with different constraints. So there's all sorts of work, you know, ways to work around that. And this is just our solution, and somebody else's can be just as good.
Yeah, absolutely. And then on the heat, sort of the heat usage side of things, I know you mentioned municipal heating as kind of the main thing you do. Have you looked at other applications? Like, is this clearly just the one that makes the most sense? Someone asked if you could like use the heat generated by your system to sustainably power DAC. I'm sure there could be other applications. So yeah, what? about choosing
Totally,
that.
we could, yeah, we could co-locate with the direct air capture system and sell them our energy, and we could turn it into power. So any kind of a, you know, carbon removal solution that would need a lot of power, or, you know, any other system as well, industrial processes making, you know, recycling something or making something greener. I mean, pretty much any, you know, food processing or any industrial system will need, you know, various shapes and forms of either heat or power or gas or something else. And that's kind of like a variability that we're able to provide. And it's just about bird by bird, you know, we need to get our first facility up and running and get the runtime and so forth. And then we can start focusing on fancier stuff, because we can't do everything at once, otherwise we won't do anything. And those things are down the line for us.
Okay, yeah. We had another question again about the feedstock side of things, which I'm just going to read out. So the person says, can you talk about the long-term supply chain plans for sustainable feedstock sourcing? Many biogenic CDR approaches are banking on bio-waste as the feedstock. So how do you approach kind of this long-term problem of securing the feedstocks?
Yeah, I mean, I guess they're like you just have to be able to access it where it's being generated. And so, okay, there's going to be some amount of biomass waste, and hopefully we can solve baseload power, so that stops being such a huge pressure on biomass. But in any case, I think we're looking at like in the very long term, I think we would like to be a partner to a lot of natural carbon solutions. So if you think of a hectare of forest today, and in 20 years, the amount of the mature carbon in the forest will largely be about the same, because a mature forest won't 50x in length or anything like that. So the way to actually work with these natural carbon solution systems would be to partner with them to harvest a part of that biomass away, lock it in a stable format, and put it somewhere where it's safe, and then the biomass can regrow that short-term carbon, so that then instead of 1x carbon, we have 1x plus x amount of carbon stabilized. And I think there's many ways of doing stuff, and carbon removal is really new as an industry, and there's so many interesting stuff. Like we mentioned some seaweed projects earlier. I know you've done some shows with Jovine and other people. So there's so many different ways of thinking about biomass generation, both on land and in sea and everywhere. So I think we're going to see an explosion of different forms of actually doing it, because it's just the most sensible way to draw down carbon with the biggest benefits and the least energy use. So it's a no-brainer, and that's what we should be doing at huge scale.
Yeah, great. Yeah, so another one I think that kind of goes into a little more detail on that is just like on the life cycle analysis. Could you talk a little bit about how that compares to maybe some other forms of carbon removal, but also, within biochar, how that's impacted by different variables like feedstock or anything else?
Yeah, I mean, for example, the life cycle or the methodology that we follow is puro.earth. You can go and visit it. It's openly available. So there you can see kind of like where the calculation comes from. But of course, like your feedstock, if the feedstock required pre-processing, that energy requirement will be subtracted from your carbon removal that you're doing. Or if it required transport, it would be subtracted. And the energy that you use in your process as well, any kind of electricity for auxiliary equipment and any heat and anything else that you're using will be subtracted as well. So really the life cycle assessment should really view the holistic whole of the process as okay, how much carbon are we really removing in this process? And then of course that should give you your carbon removed, but of course those things matter.
Yeah, absolutely. Okay. And then just in terms of the end use of the product, do you know what people are typically using it for? Is it soil amendment, burial, kind of what kind of end usage are you seeing for the biochar?
Yeah, I mean, carbon is a great sort of kind of like a surface area for the soil. And so where we'd like to see our biochar being used is co-used with nutrients. So really, it wouldn't be used alone or naked. It would always be used with some sort of manure or fertilizers or compost or different kinds of nutrients going into the soil. So really, I'd like to see all nutrients going into the soil have like whatever, a small percentage of carbon in there when it goes into the soil, because then it can help retain some of those greenhouse gases. So NOxes, for example, can be limited, up to 50% by biochar utilization. There's many peer-reviewed papers on this. I don't know off the top of my head which ones, but you can find many if you just Google it. And other greenhouse gases, and of course nutrient leaching and so forth. So I hope that we could find some ways to actually manage the nitrogen cycle and the nutrient cycle with the help of the carbon cycle, because that's how they naturally work together as well.
Okay, great. Just switching gears a little bit, we actually had a question from Matt from OpenAir, which was asking about that challenge that kind of helped you form the team. I think OpenAir is putting together some different challenges on carbon removal as well. So could you just talk about what that challenge was like and how that kind of set you up well to get started on this?
I think it was the original Carbon X Prize, and it was something like completely different.
Okay.
It was like, it was something like, can you use CO2 flue gas from a factory? In the end, I'm not even sure what happened, but in any case, we didn't even get into that challenge, but we got a corporate partner, Fortum, to actually sponsor our ticket to enter. And so we quickly, like literally within days, we did 3 all-nighters and did the whole whole pitch and like all of the application documents and bought some company that was 2 weeks old and like literally just existing for that reason to be bought quickly, and just got going. And then we were like, well, now we're at it, so might as well keep going.
Got it.
Yeah, it's a great way to, I mean, me and Chris really, we met at that program, and that was such a great way to bring people together from different walks of life and different experiences. And I'm more of the entrepreneurial person. I'm not a scientist. So really, I'm more of the person who drags stuff out into the real world. And then Chris was more of an inventor type persona. And I think that mix of multidisciplinary teams can be really, really interesting. And that's, I think that's the sweet spot. And I think post-COVID, people are like dreaming of meeting other interesting people to start cool stuff with. So yeah.
Definitely. Okay. And then I think we've kind of always asked this, but in terms of the regulatory environment, either in the US or in Europe or anywhere else you're familiar, what kind of things are working well for you? What are you hoping to see? Yeah, just anything on that front, really.
Yeah, well, the EU has now, recently come out with carbon removal as one of, like, they're working on a framework for that. So that's really, really, really cool. And I believe biochar was mentioned. I'm sure it will take years before anything is actually formulated. But it's nice to see sort of like the big wheels turning on sort of carbon removal as a whole. So that's excellent. Obviously, we would like to have a very trustworthy way to really accredit carbon removal. So there's a bunch of standards out there that are, Puro, now Vera came out with one, and so forth. And then like there are large customers who also have their own sort of questions on top of those standards and kind of mixing some of the things from them. And then I'm worried that there's like, everybody's just going to start new standards and then it's going to be a mess. But in any case, I'm sure we're going to see more and more sort of professionality in that in the coming years. So hopefully that will get better. And in the US, great on the grants front. Maybe I will say US and Europe, like both places, really, we need to globally work on first of a kind facility financing. It is way too slow. It's way too cumbersome. It's not going to be taken care of by the private market. Like it just needs to be a lot faster, whether like I have friends in different domains of climate stuff, for example, making alternative proteins or other types of gases or something else. And it just means that like everybody has the same challenge. Your first of a kind proof of concept factory is just going to be such a headwind to finance. And if that was faster, that could literally shave off some years of people's effort. So really kind of like, how do we bridge that gap between like we could call it an industrial pilot. It doesn't even need to be the first commercial unit, but somehow bringing the financiers closer to the first project. And then of course, like from governments and other, you know, entities, how do we really push the financing of those first facilities further up? Could we say, we'll guarantee government loan 60%, find the 40% yourself, or whatever it is? I don't know what exactly would be the thing. They don't need to be all grants, but it needs to become a lot more, you know, nimble.
Yeah. Okay, great. I'll do one last question just before I hand it back to Toby. When you kind of think about the future, what are the biggest challenges that you're still facing and biggest opportunities that you see?
I mean, there's a list, right? I choose not to think about too much of the crazy challenges, not to get too demotivated. No, but all things aside, I mean, you know, what would I say? Everything's a challenge, but if you have like a good team in place, if you find good people to ask for advice from and so forth, then nothing is kind of insurmountable. I'd say that right now, you know, challenge is just trying to do stuff at industry standard when you're not at industry standard yet. So really the learning curve is pretty steep. So really, you know, contracting in a manner that, like you would have existed already for 10 years and all those things. But really it's about finding the team and really kind of doing the hard work first. So really making sure that you do all of the mistakes and all of the testing possible on your smallest rig, not on the largest one. And yeah, trying to be good in those ways. But yeah, sorry for such a generic answer. I can assure you we have challenges.
Yeah, I'm sure. All right, well, this has been really great. Thank you so much, Henrietta, for joining us. And Toby, I'll give it back to you for next week.
Thank you, Megha. And thank you to the audience for all of the questions, the enthusiastic questions. Thank you to the biochar community for coming out in such force. Thank you to Ron Larson and Kathleen Draper, who helped spread the word to the biochar community. And especially thank you to Henrietta for being here with us at, I guess, early in the evening. And if you're in Helsinki, right?
Yeah, I'm in London at 6 p.m. So
okay.
I'll go and put my baby to bed next. So yeah.
Okay. Well, it's really fantastic. We were so excited to learn more about what you're doing, and congratulations on all the success. Congratulations on breaking ground this week on your new facility. And we look forward to watching as you advance and scale the business.
Yeah. Cheers. Thank you so much, everybody, for coming. And yeah, I'll read the comments. Thank you.
Just a couple of quick words, programming notes from us, if my computer loads. Here we go. So we are back with this is CDR, and our first return guest is next week, Marty Odlin from Running Tide. Their business has changed quite, or their process has changed and evolved quite a bit since they were on, and he was interested in coming on to tell us what's new, and we are excited to learn about that. So that's next Tuesday. We should be putting links in the chat to register for all these upcoming this is CDRs. Chris, if you could do that, that would be fantastic. On the 24th, we have Carbon Capture CEO Adrian Corliss. He's going to come on and talk about Carbon Capture is a U.S. direct air capture company, the name of the company notwithstanding, and they have a very exciting planned deployment in the U.S. state of Wyoming, a 5 megaton deployment, which is, if not the largest, one of the very largest CDR deployments that have been announced. So we're excited to learn about that. Then on the 31st, we are very pleased to be welcoming Stacy Kauk, who runs carbon removal procurement for Shopify. And she's going to talk about their pioneering carbon removal procurement program. And also they've recently published a really great buyer's guide for carbon removal. It's increasingly clear that, you know, we need to scale up the supply of long duration carbon removal, but to do that, we need more buyers. So she's going to talk about how we can make that happen. So lots of great stuff coming up. We'll be announcing February sessions soon. Thank you again for being with us. And especially thank you to Henrietta for such a great presentation. Everyone be well, and we will see you next week.